Hello and welcome to Bloomberg Quint. My guest today is Mr. S.M. Vaidya, Senior Executive Vice President and Business Head of Godrej Aerospace. Mr. Vaidya, thank you very much for joining us on Bloomberg Quint. We are at your aerospace division here, which is playing a big role in as far as Indian space is concerned. Let's start with you began the entire operations in 1985, right?
That's right.
And since then, how rapidly you've been able to expand this entire operation?
Yeah, so 85 to 95, I will put that was more of a learning phase for the organization, for ISRO to interact with industries. But 95 onwards, it got really a good momentum. And first we produced the Vikas engine, which is a French technology, and that was meant for the PSLV second stage. However, in the late 90s, they also coined the GSLV Mark II, which had similar usage in the second stage of this Vikas engine. And that's the time when ISRO started thinking about the cryogenic technology. And then we started working on the cryogenic, which is used as a third stage in the GSLV Mark II. And then as an extension of this GSLV, the Russian technology, the fully indigenous Russian, the cryogenic stage was built and designed. And we started participating in those cryogenic engines also, which is a C-20 that was used in the recent Chandrayaan.
This is the GSLV Mark III one.
Yes.
Which is entirely indigenous, basically.
Which is entirely indigenous, right from its solid booster, first stage, which is core of twin liquid Vikas engines, and the second stage or the next stage, which is of the C-20, that is a cryogenic engine.
So let's talk about the Chandrayaan 2, because we're going to see that landing tomorrow early morning.
Yes.
What exactly has been your Godrej's contribution into the entire Chandrayaan 2 project?
Yeah, so for any mission like this, there are three major steps which are required to be really designed and understand and conceptualize. First is a launcher, which is used to really take off that big mass of almost 4 tons. And that will go into various orbits before it goes into its final destination. So on a launcher, we have these liquid engines plus the cryogenic engines, and in the first stage and then the second stage of the GSLV Mark II and Mark III. And then when you have an orbiter, which is actually going to pass through a number of orbits before it goes on to the moon. So it requires also its own propulsion system, which is called as a thruster. And it has various thrusters which are used right from very small thruster of 5 lbr to a very large thruster of 880 newtons. So we have also a complete range of these thrusters. The critical parts of that are made at Godrej. And that helps in moving the satellite from one orbit to other orbit, and when it goes into its final slot, still because of the other forces it keeps on dragging. That means it doesn't stay in the slot. So every week or every month, depending upon how much drag you can tolerate, you fire these small thrusters and bring it back to its desired location. So that's the way you maintain the location of these satellites in various orbits.
So, currently what we see is that the orbiter is almost above moon, and now it's going to gradually descend to the south pole of the moon.
Yes.
And that's where your thrusters will play a bigger role, right?
That's right. So this is the first time the thrusters are used on reverse journey. That means, as I said, thrusters or engines are normally used where they will be used to work against the gravity. That means we will be taking off from the main Earth and going into orbit. And earlier Chandrayaan also we had the orbiter which was moving across the moon. But now, in addition to the first Chandrayaan, where we dropped about 27 kilograms of a payload, but that was a crash landing. Now we are going to do the soft landing, because we have a lot of payload, and basically the whole idea is that we want to have a rover which must get protected when we are going to land, and then it should come out smoothly and then go across the surface of the moon for almost 14 days or 1 day on the moon. So that's why these thrusters are going to be used for reverse. As you know, when the ball comes down, when you throw it up, gravity will start pulling it and the velocity will start increasing. If we are not able to control that velocity, it will have a crash landing. Whatever may be the landing gear cannot absorb such a shock, because the velocity at which it is going to get towards the surface of the moon is going to be very, very high. So therefore these thrusters will be powered once again as if we are taking off the launch, and slowly these thrusters will be applied kind of a brakes. That means their power will start reducing, and the gravity pull plus the reverse thrust what these thrusters are producing, there will be an equilibrium which will be achieved, and at that equilibrium point they will have the smooth landing or a soft landing.
You know, you've also been involved with the PSLV project for a long time now. Now we are hearing about commercialization of PSLV project going forward.
Yes.
Where are we on it? What kind of program you foresee this to become going forward, where private sector plays a major role in it?
I think ISRO has done a fantastic homework of how this PSLV productionization can happen. I think they are through with most of the government clearances, which is a mandatory in this particular case because it's a very guarded technology which is going to go into the private industries. It's not that private industries are not trustworthy, but international laws requires it to be properly protected. So I think after completing all this now, yesterday the 6th of September, there was last date for submission of the expression of interest. And let's see now how many companies come forward to take this challenging job of taking the entire operations of manufacturing, assembling a launch vehicle and handing over it to ISRO for the actual launch. And I think the manufacturing teams or the industries which are already there, they have taken active part. Plus those who were not in the part of the ISRO's family earlier, they are also very keen in demonstrating their skills in project management, in doing this integration at various stages. So now the real tough decision with ISRO will start as to how to really choose the best consortium, what they are looking for.
So this is a company, new company they formed, right? The new Space India company.
That's right.
Where ISRO will have 51% and the private sector will have 49%.
Correct. I mean the percentages may change here and there, but this is what is the concept, that they will have the majority stakes and the private industry will slowly graduate from the manufacturers to the integrators to the marketing and to the actual making a launch vehicle ready, which has been traditionally for last so many years has been done by ISRO. So private industry has to learn a lot, and I think this consortium approach between ISRO's own company and the rest of the private industries looks to be a much better and a safer approach.
And what happens to the GSLV program, because that's something where you also already have a sizable contribution. Where are we seeing the GSLV program going forward from here?
I think GSLV, the Mark II, which was using Russian cryogenic engine, I mean Russian design, of course, manufactured in India fully now, and further improvised also, but has a limitation of the payload. It can take maximum 2 tons of payload, and that is not sufficient for the current satellites which are being used for either geosynchronized communication satellites or Earth observation satellites, and that is where we need to go for a 4 ton. So GSLV Mark III,
right?
Yes. So Mark III is a very
the same platform which took the Chandrayaan. So that's the one which today I feel that has a very good, the capabilities, and that is what ISRO will focus in the coming days, and they will have more and more launches. Simultaneously, ISRO has also planned much higher tonnage of engines so that the payload can go from 4 tons to 8 tons or even higher. Can Mark III take care of that, or you need to improve the engine for that?
Mark III itself can be taken care, but not in the current configuration. It has to have a new engine, a powerful engine.
Are you working on that with ISRO?
Yes, so that is called as a semi-cryo engine, and Godrej has already been awarded the contract. A lot of progress has been done. Of course, we'll have to wait for some more months to really get that engine tested. It's a very large thrust, almost 200 tons thrust of capability this engine has, and it's beautiful. I mean, once that engine comes in, the payload capacity will go from 4 tons to 8 tons, and in the lower Earth orbit it can be even 10 to 12 tons also, so it's a massive.
And if I'm not wrong, India's next big mission is the Gaganyaan, right?
Yes.
And the semi-cryo is going to play a big role there.
Need not be. I mean, currently the configuration which is there for Gaganyaan in 2022 can be obtained using the current GSLV Mark III, with little modifications, of course, because now we are going to carry first time a human in space. All these times we have been only taking satellites. So there was no life on those satellites, or there was no need for them to be brought back. So now this engine and the capsule, it all depends upon how well the capsule will get designed. The capsule will have a lot of additional requirements for humans to stay and humans to survive inside that and safely come back and land onto the Earth. But in my opinion, whatever I have heard today, it is the GSLV Mark III which will be taken first. And in future, when we are talking about space station and larger payloads of human in space, then this semi-cryo will be definitely helpful. But of course, as we see that in Chandrayaan also, the Russians and Americans are able to reach in 2 to 3 days, whereas we have taken almost 50 days to reach there. That's because we don't have a powerful engine. So once we have a powerful engine, many more missions can be well planned and achieved. So semi-cryo is the important engine to be developed as quickly as possible and productionized and tested in space.
So that production and testing is underway, where Godrej is working on it. There.
I mean, there are many industries, but Godrej is one of the important partners because all 6 assemblies of that are being made by us.
Okay. And in a year, how many engines are you making for ISRO now?
Roughly it is about 8 to 10 engines every year, but we are currently in the process of ramping up to almost double. And if the PSLV privatization really goes well, I mean, it is already on the cards, but it has to search many more customers from the international market. And it is expected that the business opportunity is that we will be able to have minimum 18 to 20 PSLVs which are for the foreign countries or for the customers who are based abroad.
This is per year?
This is per year. So PSLV itself is going to increase our production from whatever 8 to 10 engines we are doing to 18 to 20 Vikas engines what we make. And in addition to that, there are programs from Government of India plus GSLV Mark II, Mark III and a semi-cryo which will be named maybe Mark IV or something like that. So it's a huge. So we are now actually doing 20 to 24 engines every year is the planning which is underway, and we'll be putting up a new facilities.
Put in new facilities?
Yes, we'll be putting a new facilities very soon.
And this
at
is
Khalapur.
At where?
At Khalapur near Panvel.
So this facility will move there, or
No, we will operate this facility also. And in addition to that, that new facility will come with the latest technologies. I mean, as we just said, that we established in 1985. So some of our machines or facilities are outdated, so we need to replace them. And that process has already started.
So when do you expect the new facility to come in?
New facility, I think in next 3 years we should be starting the production there.
Tell me something about this human mission which we are talking about, because after Chandrayaan 2, that's the next big one which we are going to look at. What kind of challenges are there for that mission, and from Godrej's point of view, where all you are able to bring in your expertise into that mission?
So as far as the human mission challenges are, one is the same launch vehicle which is going to take off. The reliability has to go up much higher. That means we are today maybe at 98, 99. We have to reach as close as 100%, so that no failure happens while the capsule is being launched. So that will be the worst. At the time of launch only, if the failure happens or any something which is undue happens, it will not be good. So the reliability of that has to go up. While integration assembly, because there is a human in space or the capsules, so hygienically also all the assemblies are required to be treated so that no bacteria or any germs can go along with the manufacturing itself or assembly of these rockets. Then the next phase is that it is going to orbit. So when it is going to orbit across the Earth, that time we should not see any undue forces, and if those forces come up, the shock absorption or the accelerations which these satellites are going to see, so should not get passed on to the human body, because human body has resistance up to certain force on the gravitational. Beyond that, if it goes, then the blood vessels and others may have an impact on it. So how to insulate the entire the mass or the human inside that capsule is the second challenge. And the third is that because we are going to have the humans, how to carry oxygen, how to carry their food, how to have their all other disposal systems in that area, and fire protection plus rest of the other, like any aircraft when you design. I mean, when you design an aircraft which is unmanned, it has much lower. I mean, it can be done in 1 or 2 tons of the entire mass. When you take a fighter aircraft where there is only one pilot, and I'm not saying that he is ready to die or something like that, but I mean, it is by design, it is an unstable design, so that he can have a good maneuverability and like a bicycle.
Yeah.
But when you go for a civil aviation, it has to have a very stable, because more than 200, 300 passengers are going to be traveled. And then the mass of that entire thing goes up to 60 tons or 80 tons. So from a 2-ton what unmanned this one, now we are going to go to 60 to 70 tons. And that adds because of all those systems which are required for protection and safety. So similar things are going to be required in this human in space program, the Gaganyaan program.
And will you be able to supply those engines which will able to take such high payloads?
Yes, of course. I mean, we are developing that semi-cryo which is going to take this higher payload. But most important, I think we have already reached to our yield, which is much better than 99% or something like that. Our rejection rate is controlled, it is less than 1%. But now for anything which is going to go to human in space, should not have a non-conformance anywhere in the entire, the lakhs of dimensions which are required to be controlled, or the non-destructive tests which are conducted on it. And that is going to be our biggest challenge, that how do we produce that it will have in those lakhs of inspection stages and the dimensions and the non-destructive tests, nowhere it should have a non-conformance.
And what about the re-entry? Because that will be the biggest challenge.
Yes, so re-entry is another challenge which ISRO is working on, because when you come towards Earth, so when we take off, we are going from a denser air to a much lower density of air, or almost in a vacuum. And the temperatures are going to be negative. But when we are entering it, we are coming towards higher density. Because of the gravitational force, the accelerations are going to be much higher. And plus, the density is going to create temperature. So we are going to see very high temperatures. We know that the Kalpana Chawla, one small tile came up and the temperature got so high that finally the metal got melted, the metal in which they were all capsuled inside. So that is the challenge. Not only the challenge of developing a ceramic, but how to really make those adhesives so that the ceramic gets properly adhered to it and it doesn't come out. It can withstand those abrasive forces, it can withstand those frictional forces, and still continue to perform its insulation properties which are mandatory on this capsule.
Are you working on the composites part of it as well?
Not currently for ISRO. We just made a beginning. Otherwise, at Godrej for last 3 decades we have been into metallics.
Yeah.
But now we have made into rubber and composite entry. And currently our composite is being used by BrahMos, supersonic cruise missile.
Yeah.
But we are in discussions with ISRO in case we can also start supplying it to them.
And that would be a big opportunity as well?
Yes, composite currently is a very big opportunity. It gives very good strength to weight ratio. No other metal can give it. The second is it has very good corrosion resistance. Some of the chemicals or some of the fuel and oxidizers which are used are highly corrosive. So composite gives a good corrosion resistance against it. It has certain the physical properties which are unmatched with any of the other metallics, and I think composite has a good stand. But of course it has the environmental issues also. So a balance between environment and compromise on some of the design aspects are required to be dealt in the coming years as we are becoming more and more sensitive towards the environment.
So in a nutshell, we can say that the next big challenge for you would be the semi-cryo
Yes.
engines which will be there, and the Gaganyaan project where you will be playing a big role, right? Mr. Vaidya, thank you very much for joining us today.
Thank you.
Thank you.